Let's learn how to graph factored polynomials. The key is to find the x-intercepts. Now I also want you to be aware of the type of x-intercept, and that depends on the exponent on the factor. I'll show you that in just a second. I want you to determine the end behavior. That will be based on what we saw on the previous slides, and then all you'll have to do is draw a smooth curve through the points. Here is the function I want us to graph. It has a degree of 6 with a leading coefficient of positive 1. If we factor it, and factoring these is unit 2, not unit 1, so you'll have to be given this in unit 1, is that the x-intercepts are negative 2, positive 1, and positive 3. If you're wondering why we flip the signs, it's simply because we're setting each of these terms individually equal to 0 and solving for x. By solving x plus 2 equals 0, we move the 2 to the other side and we get an x-intercept of negative 2. Here the x-intercept will be positive 1 and positive 3. The order of the intercept is the exponent on the factor. Here this is x plus 2 to the power of 1. This is x minus 1 squared, as in that factor came out twice when we factored it. And x minus 3 here is cubed. That factor came out 3 times. It is order 3. Order is the exponent on the factor in the fully factored form. That's important because order 1, order 2, and order 3 x-intercepts behave differently at the x-axis. An order 1 intercept will go straight through without stopping. It actually looks like a straight line when you zoom in on the x-axis. An order 2 x-intercept will bounce off of the x-axis. It actually looks like a parabola when you zoom in. Order 3 x-intercepts will approach the x-axis as though it was going to be a parabola, but then the parabola will flip the direction it opens in and emerge from the other side. It's similar to order 1 in that if you start on the top side of the x-axis, you'll end up on the bottom side. And if you start out on the bottom side, you'll end up on the top side. But rather than blasting straight through, you approach it as though you're going to bounce and then break through. You'll notice that that's true over here. This looks almost exactly the same, actually. You're approaching it as though you'll bounce, but you will not, and you'll slowly emerge the other side. You'll have to memorize how each of these ordered x-intercepts approaches the x-axis, and what better time than to practice right now. Here we have an x-intercept of negative 2, and it is a bounce. I'm going to put a dot there to remind myself. Here, this is an x-intercept of positive 1. It is it's not a bounce. What am I talking about? It will blast straight through because it is an order 1 x-intercept. This is a bounce. You have an x-intercept at x equals positive 1, and it will bounce because it is an order 2 intercept. Here we have an x-intercept of positive 3. I will put a dot there for us, and it is an order 3 asymptote. So, the leading coefficient of positive 1, because nothing's written here, along with the degree, which we agreed was 6 earlier, and PS, the sum of the orders of all the x-intercepts, 1 plus 2 plus 3, is a degree of 6, means that it will open up in both directions, similar to how a parabola opens up in both directions because it also has an even degree. The positive leading coefficient is why I chose up in both directions. Now, if I start pointing up to the left, I need to approach my first x-intercept and blast straight through it because it's supposed to appear like a line when you zoom in on it. As I get closer to positive 1, I need to be thinking about bouncing there. And as I get closer to positive 3, I need to start thinking about looking like I'm going to bounce, but then slowly emerge from the other side. Now what you'll notice is that if I approach +1 and bounce off it from the bottom side, then slowly emerge at +3, I end up pointing up to the right as well. And that's a good check to make sure you've handled all your x-intercepts properly. If you handle each x-intercept in succession, blast straight through, bounce, or approach, then blasts through, you should end up in the predicted direction according to the degree, even, and positive or negativity, in this case, positivity of the leading coefficient, up in both directions. And so I've sketched my first polynomial. It could definitely look better than this, but I'm using a computer and not a pencil, and yours is probably going to look this rough when you do it on paper the first time as well. Thanks for paying attention, and I'll see you next time.